Hello viewers, this is Dr. D. Rajalakshmi, Associate Professor, Department of Computer Science and Engineering, SRM Institute of Science and Technology, Ramapuram campus. In the last session, we saw about first come first served scheduling algorithm. Now we are going to see shortest job first scheduling algorithm. Let's solve a problem. Before solving that, let's see what is shortest job first scheduling algorithm. It is a non-preemptive scheduling technique. The CPU is assigned to the process that has the smallest next CPU burst. If two processes have the same length next CPU burst, first come first served scheduling is used to break the tie. Now, in the given problem, 4 processes are available. The corresponding burst time also given. For P1, the burst time is 6 milliseconds. For P2, 8 milliseconds. For P3, 7 milliseconds. For P4, 3 milliseconds. No arrival time is given. So, we are assuming that all the processes are entering into the ready queue at the same time. That is at 0th millisecond. So at 0th milliseconds, 4 processes are available, but it is the shortest job first scheduling algorithm. So it is loading P4 into the CPU first because P4's burst time is 3 milliseconds. So P4 is entering into the CPU at 0th millisecond. It is taking 3 milliseconds of time for its completion. Now, after the completion of P4, the next process with the smallest burst time will be entering the CPU. The next process is P1 because its burst time is 6 milliseconds. So, P1 is entering CPU and it is starting its execution at 3rd millisecond and it is taking 3 milliseconds of time. So, totally 9 milliseconds needed for the completion of P1. At 9th millisecond, P1 completes its operation. Now, the next job with smallest burst time will be selected. The next job is P3. This is what is the job with smallest burst time. So, P3 is selected. P3 is entering into the CPU at 9th millisecond and it is taking 7 milliseconds of time. So, at 16th millisecond, P3 completes its operation. Now, after the completion of P3, P2 enter into the CPU. P2 is starting its execution and its burst time is 8 millisecond. So, at 24th millisecond, P2 completes its operation. Now, all the processes have completed the operation. We are going to calculate the completion time. For calculating completion time, we have to take values from right to left from the Gantt chart. So for P2, completion time is 24th millisecond. So we are entering here. Then for P3, its completion time is 16. For P1, its completion time is 9. For P4, the completion time is 3. Now we are going to find turnaround time. The formula for calculating turnaround time is completion time minus arrival time. For P1, completion time is 9, arrival time is 0. So turnaround time is 9 minus 0, which is equal to 9. Similarly, for P2, completion time is 24. 24 minus 0, it is 24. For P3, the turnaround time is 16 minus 0, which is equal to 16. For P4, the turnaround time is 3 minus 0, which is equal to 3. Now, from the turnaround time, we can calculate waiting time. The formula is turnaround time minus burst time. For P1, turnaround time is 9. Its burst time is 6. So, 9 minus 6, which is equal to 3. For P2, its turnaround time is 24. 24 minus 8, which is equal to 16. 16 is the waiting time of P2. For P3, its waiting time is 16 minus 7, which is equal to 9. And for P4, its waiting time is 3 minus 3, which is equal to 0. Now, we have to calculate the total turnaround time. So, the total turnaround time is equal to 9 plus 24 plus 16 plus 3, which is equal to 52. And average turnaround time is equal to 52 divided by 4 because we have 4 processes. which is equal to 13 milliseconds. Now let's calculate total waiting time. Total waiting time is equal to 3 plus 16 plus 9 plus 0, which is equal to 28. Now let's calculate average waiting time. Average waiting time is equal to 28 divided by 4, which is equal to 7 milliseconds. So in this way, we can calculate average turnaround time and average waiting time using shortest job first scheduling algorithm. Thank you.